5.7 is vertex form of a quadratic. We'll also be talking about how to do quadratic transformations. Vertex form of a quadratic follows this formula: y equals a times x minus h squared plus k. You've actually seen this before, because we did it with absolute value. If I had something like this, I know this would have a corner at the point 3,1, which I know I'll say is here. And a slope of 2, and go up 2, right 1. That's how we did absolute value transformations. Quadratic transformations are the same. It has a vertex at the point hk. That's going to be the opposite of this number, but the same as that number, hk. The AOS is at the line x equals h, so this right here is the line x equals h. If the a value is positive, the graph points up. If the a value is negative, the graph points down. And we can still use the a value as the first point after the vertex like we've talked about. It's kind of like a slope, but not really. Let's look at some practice. Here, my h value is -5. It's always the opposite of this. My k value is 4. It's always the same as this. And my a value is -2. So my vertex is going to be at the point -5, 4, right here. That's my vertex. I know this graph is going to point down because the a value is negative. This graph is going to frown. And I can use this kind of like a slope, not really a slope necessarily, but for one step to the right, I go down 2. So I have a point here and a point here. And that only works for one step to the right. It doesn't work for anything beyond that. But I can get 3 points pretty quickly without plugging anything in. At this point, if I wanted to plug stuff in, I could. I could plug -3 in for x. If I do -3, I get -2 times -3 plus 5 squared plus 4. And -3 plus 5 is 2. 2 squared is 4. So that's -8 plus 4, which is -4. This is the point -3, -4 down here. I can get a symmetric point on the other side. I don't really have room for that. So my parabola is going better than that. My parabola is going to go like this. So here, if you want to try and pause and get a step ahead of me, that might be worthwhile. Try and find the vertex of this. You might think this doesn't have a k value. The h value is 2. The k value is actually 0. The a value is 3. So my vertex is at the point 2, 0. Then this is like my first point from the vertex. I can go up 3, right 1, and up 3, left 1. And if I plug in like a 0, I'm going to get out 12. So the point 0, 12 is way, way up here. So this parabola is just going to go like this. Finally, it's very important to remember, if there's no if there's no parentheses around this x of any sort, you can actually put some in. I can always add a 0 in whenever I want. I can say that y equals -1/2 times x minus 0 squared plus 2. So the vertex of this graph is actually at 0, 2. Then my a value is -1/2. That does not mean down 1, right 2. I don't put a point here at down 1, right 2. That's not how that works. It does mean down 1/2, right 1. So I go down 1/2, right 1, down 1/2, left 1. At this point, I'm going to want to plug in some more points. So I'll plug a 2 in for x. If I plug a 2 in for x, I get 4, because 2 squared is 4, times -1/2 is -2, plus 2 is 0. So I actually have the point 2, 0, which means I have the point -2, 0 in this case. When I plug in a 3, I get -4.5 plus 2, which is -2.5. And that's a pretty nice looking parabola. So this one has roots at -2 and 2. This one had roots at just y equals 2. This one had roots at like -4.5 and -6.5. I'm not really sure if it's an estimation. So vertex form, let's find the vertex immediately. That's why it's called vertex form. And you can grab a few points pretty quickly. If you want to take an equation that is in vertex form and put it in standard form, that involves some foiling. I do not multiply or distribute this -2. I'm not allowed to do that. By order of operations, I do the x plus 5 squared first. So I'm really going to do this. And I start with this stuff here. You should be able to figure out pretty quick how these things foil. It didn't erase very well. That's small. Figure out pretty quick how, come on. how these things FOIL. Let's leave that there for now. I get x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. There's still a -2 in front of all this, and you often will forget this +4. Don't forget that +4 out there. Well, I can simplify inside that parentheses x squared plus 10x plus 25 plus 4. Distribute the -2, -2x squared minus 20x minus 50 plus 4. So it's -2x squared minus 20x minus 46. This is now in standard form. So just FOIL that x plus 5 squared, multiply by -2, add 4. Here we're given a graph. From a graph, if we have the vertex and the point after the vertex, we can very quickly write the equation of a graph in vertex form. I know that h is 4 and k is 7. So if I take the formula a times x minus h squared plus k, then I can go, well, I know that my a value, actually in this case I know the a value is -3, it's going down to the right one. I know that my h value is 4, I know that my k value is 7, and there's the parabola in vertex form. If I wanted to put it in standard form, I would do the same stuff I did over here, but I'm not going to bother showing that now. Suppose that we didn't have this point right here. Suppose we had some other point that wasn't one step off the vertex. Gosh, I can't see that are good right now. Yeah. Let's pretend like this is the point 0 or 5.5 comma 0. I don't think it is, but pretend that it is. Well, I would have this. I know this much already. I know that there's my h and there's my k, and I get that because I know this vertex. I'm pretending like I don't have these points to work with. One thing that I could do is I could take this x value, 5.5, and this y value, 0, and plug in my a, or I'm sorry, plug this number in for x right here, and this number in for y right here, and solve to find a. So I would do 5.5 minus 4 is 1.5, 1.5 squared is something, so I would have a simple linear equation to solve from there. Right now, if we solve this out, we won't get a -3 like we should because I made up this point, but you could always find it that way if you didn't have this clear point right there. We're going to talk about transformations now. Transformations are how you can use the data in the equation to show how the parent function changes. Y equals x squared is called the parent function. It's the plain old basic stripped down version of a parabola, where it's got that simple curve pointing up, it has a vertex at the origin, it also has a y-intercept at the origin, its roots are also at the origin, pretty much everything happens at the origin. That's the parent function. If we start doing things to this function, like if we were to add a 3, the whole graph would move up 3. The vertex would be here, this point would move up 3, this point would move up 3, so this point right here got moved up 3, and this point got moved up 3. And the graph would go like this. And if you were to subtract a 3, or subtract a 5, or anything really, if we were to subtract a 5, then the whole graph would have gone from here, I didn't graph that very well apparently, down 5. I can show that more plainly on a graphing calculator. Here's y equals x squared. It is the parent function. Now if I tuck in there like x squared plus 4, it moves the graph up 4. Here's my new graph, x squared plus 4. And if I take away a 6, it moves the graph down 6. So whatever number you're adding or subtracting on the outside, whatever number is here, moves the graph up or down. If I do something in parentheses, if I do like x plus 3 squared in parentheses, that moves it left 3. The original function was here, the parent function was here, got moved left 3. So if I were to change this to a minus, it would move it right 3. These are called transformations. These ones specifically are a translation. When you move things side to side, when you slide things around, it's called a translation. This is something we've talked about before. We also talked about reflections. If you remember, reflection happens when you have a negative a value. So if I have negative x squared, now the graph goes down. It's literally reflected over this axis right here. And if I had like negative, and then parentheses I did, insert a parenthesis, like x plus 2 squared, this graph would move left 2 after the reflection. So it can be reflected and move left 2. And it looks like that. Move left 2 after the reflection. The other thing we did was dilations. Dilations are when the graph gets more stretched or more shrunk and compressed. That's when you put a multiplier in front. So if I have 3x squared, all the values of x get 3 times higher. The graph increases 3 times faster. If the a value there is greater than 1, everything gets tighter. The angle gets tighter. If the a value is less than 1, like 0.5x squared, everything gets flatter and more wide. And the smaller that number is, I can do 0.1x squared, it gets much, much wider very quickly. And we can do all those things at once. We can have a reflection that comes if this is negative. I think we should do that in red probably. A reflection that comes if that's negative. We have a dilation that comes whenever this a value is present. Then we can translate things left or right, and we can translate things up or down. All those a's, h's, and k's do these things. So I color coordinated in that way. So, for example, if I had y equals negative 1/2 x plus 3 squared minus 2, I would know that it was reflected over the x-axis. And I'd say it's dilated by a factor of 1/2. Then it translates left 3 and down 2. Please don't say over 3. That doesn't mean anything. And all those transformations take place to the parent function. So I'll type in negative 1/2 x plus 3 squared minus 2. And we can compare the parent function to the new one. It was reflected, it was moved left 3 down 2, it had been reflected, had been dilated. It's opening up a little bit wider than the first one was. The last thing we're going to do is take a quadratic and put it in vertex form. I won't show all of these examples because I don't want this video to take forever. In fact, I'll probably just do a couple. When you do vertex form, all you're doing is completing the square. The problem now is we don't have a number over here, like 0 or 10 or something. We have a variable y. So the stuff we were doing before changes just a little bit. I still start by subtracting a 12 from both sides. And when I do that, now I get y minus 12 equals x squared plus 8x. And that y just kind of hangs out over there the whole time. Right now my b value is 8. So b over 2 is 4. So b over 2 squared is 16. So I add a 16 here, and I add a 16 here. This now becomes y plus 4 equals x squared plus 8x plus 16. I know this can factor into y plus 4 equals x plus 4 squared. Subtract this 4 back from both sides. I get that y equals x plus 4 squared minus 4. This is now in vertex form. The a value is 1, the h value is negative 4, the k value is negative 4. I'll do this one also because this one's a little bit on the dirty side. The first thing I'm going to do is add a 4 to both sides. And that gives me that y plus 4 equals negative 3x squared plus 18x. Divide everything by negative 3, everything. So I'm just going to leave this y plus 4 over negative 3 equals x squared minus 6. Well, my b value is negative 6. So b over 2 is negative 3. So b over 2 squared is 9. I'm going to add a 9 here, 3 minus 6x, excuse me. Add a 9 here, and add a 9 over here. This becomes y plus 4 over negative 3 plus 9 equals, and this can factor into x minus 3 squared. Now here's where some weird stuff kind of, it's not really weird, but it's new, it's different. Now my goal is to get this y back by itself. So I'm going to undo all the stuff I just did. So I start by subtracting a 9 from both sides. Y plus 4 over negative 3 equals x minus 3 squared divided by 9. I'm sorry, x minus 3 squared minus 9. Then I'll multiply everything by 3, negative 3. And that's going to give me y plus 4 equals, this negative 3 I'm going to distribute here, negative 3 times x minus 3 squared. I don't bother foiling or distributing that. And it distributes here, plus 27. Then I finally subtract this 4 from both sides, and I get that y equals negative 3 times x minus 3 squared plus 23. And that's pretty much as bad as we'll make it in this class. Thank you very much. Have a wonderful day.